everybody. Okay, so now that we have gotten some of the basic information regarding trig functions mastered, we're going to go on to find missing side lengths in a right triangle using trig. So actually we already know a way to find a missing side in a right triangle if we have the other two sides. So let's look at this first number one here. Okay, if we know two side lengths, we can find the third using Pythagorean theorem. Okay, number two, if we know one side length and the measure of the acute angles, we can find a missing side using trig. Okay, so you use Pythagorean theorem if you have two sides that are known and you want to find the third, and you use trig if you have one side known and one acute angle known. So let's look at our examples. First one. Find the missing side in the triangles. Okay, so let's see what we have. We want to find x here, and we know that one side is 7 and the hypotenuse is 25. So since we have two side lengths that we know already and we want to find the third, in this case we're going to use Pythagorean theorem. And we did this lesson already. So we know that we've got Pythagorean theorem is a squared plus b squared equals c squared. And then let's go ahead and label our triangle. Well, the hypotenuse has to be c, the part across from the right angle. And then a and b can be in either order, the two legs of the right triangle. Okay, so we said a is x, so x squared plus 7 squared equals 25 squared. X squared plus 7 squared is 49. 25 squared is 625. Subtract the 49 over and you get 576. And then take the square root of both sides. So x equals 24. Okay, number two. Okay, we want to find x. And this time we have one angle measure that we know and one side that we know. So in this case we're going to use what we know about trig. So let me write SOHCAHTOA here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so we have to figure out which one of these trig functions, sine, cosine, or tangent, do we want to use. Okay, so to figure that out, we have to look at the 28 degrees and see, okay, the x, what is the x as it compares to the 28 degree angle? Is it opposite to the 28 degree angle? Is it adjacent to the 28 degree angle? Or is it the hypotenuse? Well, we know it's not the hypotenuse because it's not across from the right angle, and so you can tell the x, since it's across from the 28 degree angle, this is opposite. So I'll put an O there for opposite. And then now look at the 15. The 15 is across from the right angle, so this is the hypotenuse. Okay, now look at our little SOHCAHTOA chart over here. Which trig function, sine, cosine, or tangent, uses O and H, opposite and hypotenuse? It's sine. So what we're going to do is we're going to say sine, and then of the degree measure. So sine of 28 degrees equals opposite over hypotenuse. So x over 15. Okay, we can move forward with this by putting the sine of 28 degrees over 1, setting up proportion and cross multiplying. Okay, so this would give us x equals 15 times sine of 28 degrees. You can type all of that into your calculator, which we've already discussed how to do, and you get x is approximately 7.042073. Okay, we are going to be able to round to the 10th place, so the first number after the decimal point. So you need to look at the 4 right there and say, okay, if that's 5 or greater, it's going to bump that 0 up to 1. But since it's not, we can just leave it at 7.0. And put that on the blank as our final answer. Okay, third one. All right, let's look at this. In this triangle, what information do we have? Well, we've got one side that we know, and we have an angle that we know. So if we have one side and one angle and we need to find another side, that means we're going to use trig. So let me write SOHCAHTOA here again. Okay, so let's see here. The 9, well, the 9, you can tell, is right next to, it's the leg that's next to the 71 degree angle, so this is adjacent. And the x is across from the across from the right angle, so it's the hypotenuse, so it gets an h. Okay, so which one of these trig functions, sine, cosine, or tangent, uses adjacent and hypotenuse? Cosine. So you're going to say cosine of 71 degrees equals adjacent, which is 9, over hypotenuse, which is x. Okay, so we can cross multiply again. So we have x times the cosine of 71 degrees equals, and then 9 times 1, which is just 9. So divide both sides by a cosine of 71 degrees. And if you round this to one number after the decimal point, to the 10th place, you get that x, that side, is approximately 27.6 units long. And that's what we can put on the blank up here. Good job, guys.